Hello guys. For today I am going to discuss about power losses and efficiency. Power losses is equal to armature circuit loss plus brush contact loss plus core loss plus field circuit loss plus friction and windage loss plus stray load loss. Efficiency is the ratio of output power or power drawn by load to the input power or power generated by the generator. Ang iyang equation is, efficiency is equal to output power or power delivered to load over output power plus power losses. Next is the maximum efficiency. Maximum efficiency occurs only when the constant or rotational losses are made equal to the variable losses. Ang iyang equation is maximum efficiency is equal to output power over output power plus 2 times constant losses. Note that in a DC generator, the constant or fixed losses are the following: friction and windage loss, core loss, brush contact loss, and the stray load losses, while the variable losses are the following: armature copper loss and the field copper losses. Sometimes field copper losses are constant, dependent on the type of DC generator. Also, unless otherwise specified, brush contact losses are assumed constant. We have an example problem. A DC shunt generator has a full load output of 30 kilowatts at a terminal voltage of 250 volts. The mechanical and iron losses are 1,300 watts. The armature and shunt field resistance are 0.13 and 125 ohms respectively. Calculate the efficiency of generator at full load and maximum efficiency of the generator. We have a schematic diagram here. A schematic diagram of DC shunt generator in which field winding is connected in parallel with armature. The mechanical is the power input and the electrical is the power output. We have the given data. The power output is 30 kilowatts and 30 kilowatts is equal to 30,000 watts. And the terminal voltage is 250 volts and the mechanical and iron losses is 1,300 watts. The armature and shunt field resistance are 0.13 ohms and 125 ohms. We will going to calculate the efficiency of generator at full load and the maximum efficiency of the generator. We have the solution here. The first thing to do is we're going to get the value of the current load. To get the value, we must divide the power output divided by the terminal voltage. The value of the power output is 30,000 and sa terminal voltage kay 250. 30,000 divided by 250 is 120 amperes. Then we have to calculate the current flowing through the field winding. The voltage across field winding is V, which is 250 volts, and then the resistance of field winding is 125 ohms. 250 divided by 125 is equal to 2 amperes. Next is going to get the armature current. In order to get the value, we will just simply add the current load plus the current shunt field winding. 120 plus 2 is equal to 122 amperes. The armature copper loss is equal to IA squared RA is equal to 122 squared times 0.13 is equal to 1934.92 watts. So sa field copper loss, ang iyang kuan is ato i-times ang ISH squared times RSH is equal to 2 squared times 125. So it is equal to 500 watts. And then total constant loss at FL is equal to 1,300 plus 500 is equal to 1,800 watts. So ang total loss niya is ang iyang kanang kuan variable loss or armature copper loss plus sa constant loss. So muna siya ang 1,934.92 plus 1,800 is equal to 3,734.92 watts. And then sa pagkuha nato sa kanang ang generator efficiency of generator at full load is muna siya ang atong equation. So output power divided by output power plus constant loss plus variable loss, and then times 100. So muna siya, ato lang siya i-substitute ang mga value. So output power is 30,000 divided by 30,000 plus 3,734.92 times 100. So calculate na ito na. Ang magawas is 88.9286%. So mo na siya ang atong efficiency of generator at full load. So nato sa ato solution sa pagkuha sa maximum efficiency of the generator, mo ni siya ang total constant loss at FL is equal to 1,300 plus 500 is equal to 1,800 watts. So at maximum efficiency, variable loss is equal to constant loss. So IA squared times RA is equal to 1,800 watts. And then ang armature current is equal to square root of 1,800 over 0.13. So muna ang answer na niya is 117.669 amperes. So IL is equal to IA minus ISH. So ang value sa IA is 117.669, and then ISH nato is 2. So 117.669 minus 2 is equal to 115.669 amperes. So output at this load is equal to V times IL is equal to, so ang value nato sa terminal voltage is 250, nya ang value nato sa current load is 115.669. So ato na i-times, ang answer is 28,917.25. So since na tay mga value, so makuha na nato ang maximum efficiency of the generator. So maximum efficiency is equal to output power over output power plus constant loss plus variable loss times 100. So ang value nato sa output power is 28,917.25 over the output power nga 28,917.25 plus the constant loss that is 1,800, and then ang variable loss is 1,800. So kani siya ato i-times 100. So ang answer nato nga makuha is 88.9289%. So muna na siya ang atong maximum efficiency, ang 88.9289%. So you can compare it with full load efficiency, and you will observe that maximum efficiency is almost equal to the full load efficiency. In our last unit, we have studied that the machine is designed such that its efficiency is always maximum near its rated load, and in this case also maximum efficiency and full load efficiency both are almost same.